Welcome to another video explaining the universe using the particle model. Today's video is about the particle model and the fact that there is no proof. First, a word about the book that Dave and I have written. Yes, that's the double apple that is the icon for our book. The large apple is Newtonian gravity, and the smaller apple inside represents level 2 gravity that we talk about in our model. You can buy the book from Amazon, hardcover, paperback, or ebook. Let's talk about proof. To prove something, you need direct evidence. If you have indirect evidence, you do not have proof. You have supporting evidence for your theory. When you have enough supporting evidence, your theory may be seriously considered. So let's talk about what direct evidence is versus indirect. Some physical events are easy to prove because we have direct evidence. The apple falls to the earth. We can see it. We can measure it. The moon orbits the earth orbits the sun. All those are the same kind of thing. This is direct evidence of motion. This is the evidence that everyone has in terms of talking about a theory of gravity. Well, Newton used this motion, the motion of the apple, the moon, and the earth, to infer that there was a force called gravity. Newton had direct evidence of motion and used it as indirect evidence of gravity, because we don't have direct evidence of gravity, we have direct evidence of motion. Motion is supporting evidence for gravity. But if we had direct evidence for gravity, then we would know what gravity really is. Problem solved. We could all go home. Somebody's got the answer. So there are numerous theories, or at least attempts, which theory is right. Newton had no theory, so it's hard to say his is right or wrong. He had a great equation. Lesage had a theory, but no proof, just like everybody else. He has no proof. He knew about motion, but not direct evidence of gravity. He had, but his theory, he did have a theory, but no proof. Einstein has general relativity, but no proof, only supporting evidence. The particle model uses the Lesage theory, and so we're in the same boat as Lesage. We have direct evidence of motion, but indirect evidence of gravity. All of these options are on the table. Yes, even general relativity. So let's talk about detecting with our senses. We can detect motion because we see objects moving. We can detect sound because we hear air moving. We have 5 basic senses. That's what we're taught. We really have a lot more. Senses that allow us to see, hear, feel, smell, and taste. We also have an inner ear detector that senses the direction of gravity. That's pretty clever. You know, that we know what upright is because our inner ear tells us when we're tilted one way or the other, no, stand this way. We're detecting the direction of gravity. To the extent that we detect an event with more than one of our senses, generally we can prove that the event is real. But we can also use instruments besides our senses. Instruments have been developed that helps us detect things that our own senses cannot. There are, for example, microscopes and telescopes, voltage meters and resistance meters, thermometers, clocks, scales, yardsticks. All these instruments help us understand, like with motion, how fast something is moving. In a circuit, what the voltages are across the resistor. Even though we can't see the voltage, we can measure them. These instruments help us learn about objects we can see and provides additional information about what we can't see. And we put all this together to try to get direct or indirect. But instruments give us indirect, usually indirect, because we're not always seeing it. Here we can see with our eyes, but not with voltage and resistance. Now here's an interesting point. Is LIGO. This is a large interferometer that was used to detect gravity waves. Is LIGO proof of gravity waves? Some people out there would say so. But let's look at the LIGO evidence. LIGO has direct evidence of the phase shift of light. That's what an interferometer does or can do. That is proof of the phase shift of light. So they can say they have direct evidence of a phase shift of light. It has indirect evidence of the theory of gravity waves will cause length contraction. In other words, special relativity proposes that a gravity wave will cause the arms of the thing to shrink, changing the distance, changing the time that light travels, and hence causing a phase shift. So LIGO has indirect evidence of the theory that gravity waves will cause length contraction. It's indirect. This is supporting evidence for the theory of special relativity. It is not proof. Well, in the particle model, I have reported the results of 2 experiments. They're both electrical. The 3-resistor experiment, comparing voltages, got really good correlation. Then the second one, also a different 3, if you will. And I compared current and got a very good correlation. But what I'm doing is measuring voltages and current, but the model is predicting that the current around the loop is not the same. This is indirect evidence, but there is no direct evidence that the G1 particle exists and is the cause of the voltage and current values. This is only supporting evidence, not proof. So to prove it, what do I have to have? I have to have something that detects G1s. There is no meter that counts the number of G1s entering a resistor, passing through a resistor, or hitting and leaving a circuit, which is the 3 things I talk about in doing when a G1 passes through a resistor. TPM predicts that the current around the circuit reduces as it flows from the negative end of the battery through the resistors to the positive end of the battery. This reduction of current can be measured. The measurements where I measure voltage resistance and then calculate the current, these are indirect evidence of the theory, not proof. Proof. There is no proof that the particle model is true. But the more supporting evidence that is found, then the model will become more acceptable. By applying TPM to many parts of physics, the analysis has shown that it can explain things that are not explained by other models It predicts things that other models do not predict. It works so well that I have asked myself, is this real? Could be, but there's no proof. So all options are still on the table. TPM is an option that's on the table, as far as I'm concerned, but there's no proof. TPM has a model that uses the G1 particle to describe a gravity field, magnetic field, electric current, and light. That's our model. It's an option and it's on the table. If you have a model and for the gravity, magnetics, electric, luminic, especially a physical model, then your option is also on the table. So keep pursuing your model. Yours may be right, mine may be wrong. My name is Bob the Hilster, and I am your particle model guru. If you have a question, ask Particle. Thank you for your attention.